Hello friends, today I'm going to talk about Leetcode 907, sum of subarray minimums. The problem is given an array of integers A, find the sum of minimum B, where every P is a continuous subarray of A. And here is the example. Here we have 3, 1, 2, 4, and we have subarrays over here. They are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 subarrays here, so we get and the sum is 7 here. And the range of the database data is so the problem that is seems a little trivial, that we can find all the subarray and then get the sums. This is the first solution here. And for the first, for example, we have this array, and for the current, we have for example, we have the I and j. We get the minimum number is 4 here. And after we have add another number 4, 5, 3, and the minimum number is 3. So we only need to compare with 4 to the 3. So so we can use these formulas. The minimum of I to j plus 1 depends on the I and previous minimum ij, and then compare with the elements aj. But this takes x o n square times still. Consider of the data length, so it will probably per TLE, because it takes about 9, 3 times 4, so it's 3 times power 4. For n, if the maximum is this, so n square should be the 9 power 8. Power 8 is probably a little time consuming, and it's better to be limited in the power 6 or power 7. So we have to come another better solutions here. And this problem is actually, we will find that we need to reduce the competitions of these minimums, because we have found there's a lot of the repetitions of the minimums here. After we get this files, if we use to get all the subarrays, we cannot avoid of this. But we have found that if we find the current, for example, we have the array 0, I minus 1, I to the I plus 1 are 3, and for the current element, we AI, for the current element AI, that if it is a smallest number, that means that all the subarrays contains that the sum will depend on this value, right? It means that, for example here 0, I minus 1, we assume that AI is the minimum numbers between all these numbers, and so we can get is how many arrays we have. we have m times so have m m arrays here, and similarly, if AI is the smallest number between all the elements after it is, we assume here there are n numbers here. This is the minimum numbers here, so we have the n subarrays here. So we combine it together, that is, we have the m times n numbers array, because each element of this one could be combined with any element of this previous layer of m element and construct a new array. So for example, here this is a new array, and this is a new array, and this is a new array. So there are m times n here, because this is also could be the constructed with m arrays, and to get the sum we have the times ai, because ai is the minimum number here. So, and then we consider the I equal to 0 to the m minus 1. So finally we get these summations here, and this is only takes O(n) time complexity. So if we can find out for every element how many m and how many n here, so the problem is transferred to get the number of m and the number of n. So we can define, and here define the number of contiguous elements using ai as the smallest value on the left of I as the left counts. This is called array. And similarly, we define the number of continuous elements using ai as smallest on the right of I is called right counts. And let me give an example here. For example, we have this array, and there are 7 elements. Let's count the left count for each element. And for the 4 over here, how many elements on the left use 4 as small element? Use small element here. Okay, something is wrong here. So there's only 1 right here, because it's only itself. So we count itself. And how many elements for 3 for the left is 2, because we use count 4 and 3 here. And this is 3, because we use 2, 3, 4 as the smallest element, and 5. Notice 5 here should be the 4. And for the 2, how many elements we use as the smallest number? Because we consider continuous element, so it's only 1, because 1 is smaller than 2. Because we also have the consider contiguous subarray, so it's 1 here, and this is also 1, and this is 1 here. Similarly, for the right count, we consider how many elements using AR on the as the smallest on the right of I. So we start from here is 1, and 3 is we consider the 3 has 3 and 4, so has 2 has 2, 3, 4, and 3, 4, right? And here 1. How many elements is 1, 1, 1 here? This is, in this way we could construct the left and right counts. So basically, is that we have to figure out how many elements on the left and how many elements in the right, so it gets the minimum number in a small range of array. So this reminds me of using the monotonic increasing stack or queue. So this is actually the important application of monotonic stack. So for the left counts, we traverse from the left to the right, from the index 0 to the m-1, and we define a stack. And after each stack, if it's smaller than the top of the stack, we will pop from the stack and count the values cumulatively, and then we update the count. Now here is at 1. When we get 4, is the first element get 3. 3 is smaller than stack 4. 3 is smaller than stack 4, and so we will pop 4, and count is plus 1, plus this 1 plus 1 is 2 here. So now this here. So in this way, we could construct the left count. Similarly, we could also construct the right counts from traversing from right to the left. We also construct a monotonically increasing stack and get the right counts here. And this is actually application of monotonic stack or queue. Whenever we have to get the minimum or maximum value in a small range array. So this is the idea of this problem. Let's write the code. So first we define the model should be the this range, and we define the length of this array. Okay, maybe we should consider some corner case. If the A is empty, we directly return 0 here, and then we define the counts initialize at 0 here, and right counts initialize at 0 because the element itself is the minimum or maximum stack equal stack for I equal in 0 and n over here, count equal to 1. We while loop to pop the count if the stack is not empty and the current element is smaller than the stack at top value. We pop from the stack. Before we probably update the counts, left counts value. Then we stack the pop. And we put element in the current element in the stack. We can put the index. That will be easy to code. And similarly, it's for the right left. For right left, we traverse from the right to the left. And here we should be the right, left, and stack right here. And we have found that whether if is equal or here is equal, actually we can only have one equal here, because this is only for the cases if there are duplicate numbers here. For example, here 1, 1, 2, 1, 1, 2 here. And in this case, we will have left count and right count. They will have duplicated calculations. So only one equal is allowed. When there are duplicate numbers. Then we update the answers, use the formulas here. That is current value times left counts I plus right counts, and modulo, then we return answers. So basically this is run the code. Okay, so try to run it again. Something is wrong here. 85.7. What is 85? So this is this should be the 9, and also this should be correct, and minus. Okay, we made it.